Hello, my name is Praharsh Singh, and this video is part of the experiment 4 of DSP lab, and it basically requires me to pass a PPG signal through through LPF and HPF filters uh, to perform the filtering operations. So in this experiment, the high pass filter had the cutoff frequency at 0.5 hertz, and the low pass filter had cutoff frequencies at 10 hertz and 30 hertz, and also the sampling frequency was 100 hertz, and the given signal had 1000 elements. So I would be performing these operations on this board, Arduino DA board. And so moving on to the code part. So float x, this basically is uh, the given signal, and is the size of this signal. And we have created three temporary arrays which will be used and in this code. So in y would be storing the high pass output, z would be storing the high pass filtering output of 10 hertz, low pass filtering output of 10 hertz, and low pass filtering of 30 hertz in the z30 array. So moving on, so we define the baud rate at 9600. We now set three functions, hpf and lpf10, lpf30. So basically these functions would be responsible to for the filtering operations. So to design the filter, we evaluate the hpf expression. This was the expression that we were able to evaluate using the pole zero placement method. And utilizing this formula, we can now you can now we are now able to pass the signal and have its high pass version of the signal. So y of I is the high pass version of the signal, which is basically y of I equal to 0.9685 y of I minus 1 plus 0.9843 x of I minus x of I minus 1. This basically is a feedback based equation, as a previous term y of I minus 1 is also present. This basically is a for loop, and this does the HPF operation. This function we are required to include star, basically because we are passing arrays through the blocks or HPF functions, through the functions. And now we perform LPF10 operation, basically whose cutoff frequency is at 10 hertz. So it's basically input would be the from the HPF filter, and the output would be Z. HPF30 would have its input from the HPF filter, and its output would be Z30, stored in Z30. So these are similar to that, only the expressions or the coefficients were changed, and this was changed based on the pole zero placement method. And now for the calculation uh, for the pictorial view, we would be plotting the signals. So the input signal would be plotted in blue, the high pass filter would be plotted in red, low pass filter having 10 10 hertz has its cutoff frequency would be plotted in green, and low pass filter having 30 hertz as its cutoff frequency would be plotted in yellow. So xi is our input signal, yi plus 200. This dc is added just to this helps us in differentiating the curves. So now I'll be running the code. This dc helps us to uh, separate out each of the component, each of the outputs. So basically by z30, z30 would be at the top, then z10 is basically 10 hertz, z, then y, then x. So now we shall look at the plotter output. This is the output, and this is our input signal in the blue. In the reds we have our signals from passed through the high pass filter. We can see some of the high pass some of the noise has been removed, and after we pass it through the low pass filter, we can see that much of the high frequency noise is removed, uh, as is evident from the green green graph. And if we pass it through the 30 hertz, having the frequency as 30 hertz, we can see even more, it seems it is smooth even more. So basically these are basically the conclusions that we can make from the following graphs. And um, so this concludes the evaluation and estimation of my of for this experiment, or the observation for this experiment. Thank you.